you in the previous class about the repeat construct. So when you even if there is a number in this place, or even if you have an expression, so if you have an expression, okay. So if you have an expression n minus 1 tick b1 means n is a value. Let us suppose n is equal to 10. So 1 tick b1 means 10 minus 1 is equal to, this expression will be evaluated, okay. This expression will be evaluated and the value of the expression is taken into consideration. 9 times this block will be repeated, okay. 9 times the block will be repeated. That is the meaning of the repeat statement, okay. Repeat statement. Here this begin and block, okay. This is the begin and block. This is executed uh, n minus 1 times, okay. N minus 1 times. So during the positive edge of the block, you execute these two statements. So you need to assign out is equal to m of march. See, ఇది ఒక program ఏంటిదంటే, so I have not given you module inputs, outputs, nothing else is there. Okay, simple thing to show you. You can use this particular procedure and you can design anything and you can write any program depending upon this logic. So out is equal to m of mark. M may be anything and mar may be anything. Okay. So mar is equal to mark plus 1 tick p1. These two statements will be executed at each and every positive edge of the clock. They are executed n minus 1 times. Okay. So output and here the output is n successive words. The data to be output are available in n successive locations of the memory. So here the output is the output. Okay, output is the output, and the output activity takes place at every positive edge of the clock and is completed in n cycles. Okay, so this is about repeat construct. దీంట్లో నేను మీకు ఒకటి చెప్పాలి, disable construct, right? Disable construct ఒకటి, ఇంకొకటి what is the last one, force release construct. Okay, we will be discussing disable and force release. So I hope you all clear with this. Okay, wait construct, it will wait, expression is evaluated. Okay, I'll just give you briefing. Wait construct low, first expression is evaluated. Okay, wait a ampersand b. This expression is evaluated and hash to c is equal to hash to c is equal to b. And you wait till this expression is evaluated. Okay, so after that, after 2 seconds or 3 seconds, you assign the value of b to c. Okay, so that is wait construct. Case construct means if you have multiple cases. Okay, so depending upon select line or depending upon the input. Okay, depending upon this, if this is the input, you should get the output is equal to 1 0 0 0 1 1 0 1 1. These are the inputs. Depending upon the inputs, you should get the output. Okay, so these are all the cases. 4 cases you need to take. I told you, if there is a case statement, you need to use default case. It is up to you. If you are using case, you need to use end case. Construct, if else, if construct and if else construct. Okay, this is also conditional statement. Okay, so if any expression is true, then you execute the next statement, or else you can quit. Assign, deassign. So whatever the value you want to assign, use assign statement which is continuous. Okay, so if you want to deassign the value which is assigned previously, use deassign construct. Repeat construct means repeat a particular block for certain amount of time. Okay, so all these things covered. దానిలో ఇవి రెండు గుర్తు పెట్టుకోండి. దీనిలో disable and force release. Okay, this is the next slide, part 5 of behavioral modeling. Next important thing is we will see the for loop. Okay, so for loop is quite similar to for loop in C. Okay. So first thing is you need to check assignment. Okay. So check the expression, execute this statement, and go to assignment 2. Okay. So here you can see execute assignment 1. Okay. First execute assignment 1. This is the first step. Okay. Second step is evaluate the expression. So evaluate this expression. This is the second step. Third one is if the expression evaluates to true, carry out the statement. Okay. If this is true, so you execute this statement in the third step. Okay. So next, in the next step, what you will do? You will increment. Okay, increment and use test another. You will go to assignment. You will go to this is the third step. Okay. Again, repeat. This is a repetitive loop, kada. So again, 1, 2, 3. Sorry, 1, 2, 3, and this is 4. Okay. So 1, 2, 3, and this is the fourth step. Okay. So after 4, again this is a cyclic process. Check for assignment 1. Check for the expression. If the expression is true, execute the statement and increment. Okay. And again go back to 4. Again 1, 2, 1, 2, 3, 4. Okay. 1, 2, 3, 4. Okay. For loop goes like this. Okay. So this is the assignment you need to express. You need to. Okay, so this is the assignment you need to do. Next, check for the expression. If the expression is true, then execute the block. Okay, execute the block and execute assignment 2. Go back again. Okay, so go back again. And cheppan kada 1. This is assignment. Execute the statement. Ikkada untadi for. Okay, then execute this block. If the statement is true, go to this block and execute, and again go to statement 3. Okay, so 1, 2, 3, and 4. Okay, 1, 2, 3, and 4. Again, fourth step ayin tarvata again go for 1, 2, 3, and 4. Okay, so like that, this is the flow chart for the for loop. It may be compared for the if-else construct. In general, whenever one has to accommodate alternatives for execution, if and if-else constructs are preferred. Okay. Sequence of assignments unnappudu entante it should be done repeatedly with an index for termination. Okay. So we will see that. So example for loop, memory load program using for loop. So here you can see we have a register of m locations. Okay. So we have red 7 down to 0. Each of red 7 down to 0 and 15 15 down to 0 ante. So reg is of, you can see here. So a reg is of 7 down to 0 ante. You can see. So M is having 16 locations kada. M of 0 నుండి M of 16 వరకు. Each location is of 8 bits. Okay, 7 down to 0 ante. Each location is of 8 bits. Okay. So total number of locations will be equal to ఇవన్నీ locations ఎన్ని చెప్పండి. 16 into 8 will be equal to what?
128.
Sir, 128 locations. Okay, 128 locations. So now we are taking a temporary integer value I. So ముందు కూడా ఇట్లాంటి ప్రోగ్రామ్ చేసినట్టు గుర్తొస్తుంది నాకు. ఓకే, రెడ్జ్ క్లాక్ ఆల్వేస్ బిగిన్. ఓకే, దీస్ ఆర్ ఆల్ ది కామన్ థింగ్స్. Clock we are taking in a reg. Okay, clock we are taking in reg. And the next thing is you need to execute this for loop for I is equal to 0. First check whether I is equal to, I will be starting from 0 only. I is equal to 0. So I is equal to 0 అని ఇచ్చాం కదా మనం first. Okay. So 0 is less than 8. 0 is less than 8. Okay. ఇది first, ఇది second. 0 is less than 8. 8 register with 15. Okay, let it be whatever. Okay, I is less than ఇక్కడ మీకు 0 నుండి 7 రావాలి. 0 నుండి 7 రావాలి. Okay, here what is this? 6, 15 to 0. So anyways, it will be 128 locations will be there in this register. Okay. So I is less than 8. Yes, this condition is satisfying. So this is the second one. Third ఏంటిదంటే మీరు ఇంక్రిమెంట్ చేయొద్దు. You execute this during the negative edge of the clock. During the negative edge of the clock, what you need to do, m of I is equal to I into 8. Okay. So this is the what you need. ఇక్కడ ఏం చేయాలి? M of I. M of I is equal to M of ఇదేంటి M of 0 కదా. M of 0 will be equal to what? ఇక్కడ రాస్తున్నాను. M of 0 will be equal to what? 0 into 8, which will be equal to 0. Okay, which will be equal to 0. And for I is equal, this also you need to execute. For I is equal to 0, I less than 8. At the negative edge of the clock, you are displaying this thing. It is a display command. Okay, that's it. Next one is, okay, ఇది execute అయిన తర్వాత third what? The execution is the third step, and fourth step you need to go here. One second. One second. Sorry. So third, next one is what you next. This is the fourth step. You increment the value of I is equal to 0 plus 1 is equal to 1. I plus 1. Okay. So this is I plus 1. Okay. I is equal to 1. Okay. 1 is less than 8. Yes. M of, now what is this? M of, you need to execute. ఈ రెండు అయిపోయిన తర్వాత execute this. M of 1 is equal to 1 into 8, which is equal to 8. Okay. And during the negative edge, you display these things. Next one is, again, you increment the value of I plus 1 and I is equal to 2. Like that, 2 is less than 8. Okay. So M of 2 will be equal to 2 into 8 is equal to 16. Okay. So alane, you increment till I less than 8 ante 8 you should not take, till 7 only it will take. So 7 is less than 8. This condition is true. And then you execute I of M of 7 is equal to something, 7 8 56. So I of 8 ante 8 less than 8. This condition is false. Okay. When this condition is false, it will come out of the loop. That's it. Okay. So we will see the output of this one. 0, 8, 16, 24, 32, 40, 48 and 50. Okay, for loop kuda in the same way. Now 8-bit adder. 8-bit adder using for loop. Okay, for an 8-bit adder, sum is equal to, okay, yes, sum is 0 and output is C0, input is A and B, simply AB, okay, output is C0 and here output is, what is this? Sum is the output and enable is one input and carry in is also one input. So output you are storing in a reg, okay. So yes, integer always at the positive edge of the enable. When enable is equal to 1, when enable is equal to 1, what are you doing? Carry out is equal to carry in. Okay. So yeah, whatever the carry in is there, you are just assigning that to carry out. So for I is equal to 0, I less than 1. So what you need to do, you need to check condition I. Okay, I is equal to 0. So 0 is less than 7. This condition is true. And you need to execute this statement. What is this? C of I plus 1, comma, A, what is this? A of I plus B of I plus C of I. You are adding and you are assigning to C of I plus 1 S of I. If there is a carry, if there is a carry, so here C of I plus 1 will be equal to 1. If there is no carry, this will be assigned with 0. Okay. So end and whatever the C of 8th bit of the carry is there, that is assigned to C0. Okay. So this is your 8-bit adder. You can execute with for loop. You try this one. Ma, are you able to see the screen, all of you? Screen కనిపిస్తుందా?
Yes, ma'am.
అంటే నెట్వర్క్ ఇష్యూ అని పెట్టారు మెసేజ్. ఈ ప్రోగ్రామ్ అర్థమవుతుందా గణేష్?
అలా అసైన్ చేస్తే సిఎఫ్ఐ కి అసైన్ అవుతుంది కదా మేడం కనుక సిఎఫ్ఐ ప్లస్ 1 కి మొత్తం
సి ఆఫ్ ఐ ప్లస్ 1 అంటే ఏ ఆఫ్ ఐ, బి ఆఫ్ ఐ, సి ఆఫ్ ఐ వస్తాయి కదా. 8-bit యాడర్ అంటే యాక్చువల్లీ యాడర్ విల్ బి లైక్ దిస్. ఓకే, సో ఇలా ఉంటాయి A7, B7 అప్ టు ఇది A0, B0. ఓకే, సో క్యారీ ఏంటిదంటే ఒక స్టేజ్ నుండి ఇంకొక స్టేజ్కి దట్ క్యారీ ఈజ్ ఫార్వర్డెడ్ లైక్ దిస్. Okay, so carry is forwarded like this. So what you will be doing, ఇది ఇంకా కొంచెం simplify. This is the structure of the adder what I have shown you. So to simplify this, you have A7, A6, A5, A4, A3, A2, A1, A0, and B7, B6, B5, B4, B3, B2, B1, B0. Okay, so now what you are doing is carry out whatever you are getting. ikkada oka carry generate avutadi C0. Okay, so here I am writing carry of 0 is generated here. Carry 1, carry 2, carry 3, carry 4, carry 5, carry 6 and carry 7. Okay, so here whenever దీంట్లో ఏంటిదంటే this adder, ఇవన్నీ కూడా one full adders. Okay, first carry, that means C of 0 is nothing but C in. Okay, sorry, let me see here. For I of 0, in initial value ante I of 0 ante this is the first stage. Okay, A0, B0. So what are you doing here? A of I plus B of I plus C of I. Okay, ante A of I and ante A of 0, B of 0, C of 0. ఈ మూడు యాడ్ చేస్తున్నారు. So that is nothing but your S of 0. Okay, S of 0 is nothing but A of 0, B of 0, C of 0. Okay, so ikkada you are one carry is generated. Okay, one carry is generated, that is nothing but C of 0. That carry you are assigning to what? Ci plus 1. Okay, so sum of 0 ikkada meeku entidi C, you are getting idi sum Ci plus 1 and sum of I. అంటే ఇప్పుడు we are at I is equal to 0 కదా, so sum of I is nothing but S of 0 is generated by A of 0 plus B of 0 plus C of 0. ఇక్కడ క్యారీ ఒకటి జనరేట్ అవుతుంది కదా, క్యారీ ఎటు వెళ్తుందమ్మా? నెక్స్ట్ స్టేజ్కి వెళ్తుంది. ఓకే, సో దిస్ ఇస్ నథింగ్ బట్ Ci plus 1 అంటే ఏంటి? Ci plus 1 is nothing but what? C of 1 అంతేనా? 0 plus 1 కదా, Ci plus 1. So Ci plus 1 is nothing but C of 1 and sum of 0 is equal to Ai, Bi, Ci. That's it. Okay, సో ఇక్కడ ఈ స్టేజ్ లో వచ్చిన క్యారీ ఇక్కడికి షిఫ్ట్ అయింది అనమాట. ఓకే, స్టేట్మెంట్ ఈస్ ఎగ్జిక్యూటెడ్ హియర్. స్టేట్మెంట్ ఈస్ ఎగ్జిక్యూటెడ్ ఇక్కడ బిగిన్ అండ్ వరకు ఈ స్టేట్మెంట్ ఎగ్జిక్యూట్ అవుతుంది. అగైన్ గో బ్యాక్, I is equal to 1. I is equal to 1 అంటే దిస్ ఇస్ దిస్ స్టేజ్. ఓకే, I is equal to 1 అంటే ఈ స్టేజ్ అన్నమాట, దిస్ స్టేజ్. ఓకే, I is equal to 1. ఓకే, సో I is equal to 1 లో మీకు ఏం జనరేట్ అవుతాయి? I is equal to 1 అంటే వాట్ విల్ బి జనరేటెడ్? సో I is equal to 1 means sum of 1 will be generated and carry of 2 will be generated. అంటే ఇక్కడ వచ్చిన క్యారీ ఎక్కడికి పంపిస్తారు? ఇట్ విల్ బి ద carry of C2. Okay, whatever the carry you got here, that is shifted to C2. Okay, carry C2 and sum 1. Okay, which is equal to A1 plus B1 plus C1. Okay, so అర్థమైందా ఇప్పుడు Ganesh? Still you have any doubt? Like that, finally the carry of the 7th stage carry ఎక్కడైనా ఇప్పుడు let us suppose 6th stage carry ఇక్కడికి వెళ్ళిపోతుంది. 7th stage లో ఏదైనా carry ఉంటే what you are doing, carry out of the 7th stage will be equal to you are putting assigning to C0. That's it. So you need to, that's why you need to take carry out carry. Okay, so totally 8 bits you need to take 9 తీసుకోవాలన్నమాట, 9 bits. ఎందుకంటే అడిషనల్ గా లాస్ట్ స్టేజ్ సమ్ తర్వాత ఇంకొకటి జనరేట్ అవుతుంది, లాస్ట్ క్యారీ. దట్ లాస్ట్ క్యారీ ఇస్ నథింగ్ బట్ క్యారీ అవుట్. ఓకే, సో చెప్పాను కదా A6 B6 A7 B7. ఓకే, ఇక్కడ వరకు మనకి ఎన్ని 7 క్యారీస్ వస్తాయి. ఓకే, కానీ లాస్ట్ స్టేజ్ లో కూడా ఇంకొక క్యారీ వస్తుంది C8. ఆ C8 ని తీసుకెళ్ళి మనం ఏం చేస్తున్నాము, యూఆర్ అసైనింగ్ టు C0. సో దిస్ ఇస్ యువర్ 8-bit adder using for loop. So you can see the this is the test bench. You can give any test bench. These are the simulation results what you are getting here. So one more thing, another segment of test bench 8-bit adder. So you are taking here 2 intermediate variables. Ikkada if and for loop you are using. So what are you doing? For k is equal to 0, k less than 1, k is equal to k plus 1 degree 0 అని ఇస్తున్నారు. So this is the test bench program. Okay, test bench program. టెస్ట్ బెంచ్ ప్రోగ్రామ్ లో కూడా మీరు you are using for and if statements, and you are assigning the things. Okay. So for k is equal to 0, k less than 1, k is equal to k plus 1 tick p 0. That means you are taking a temporary variable k. Okay. So you are k is equal to 0, k less than or equal to 1 అంటే ఏంటి? K0 దగ్గర you execute this statement. Okay. And what is the statement? If k is equal to 1 అయితే, so what you need to do, carry in is equal to 1 tick b1, else carry in is equal to 1 tick b0. Okay. So again you take one temporary variable which inside this beginning block I is equal to 0, I less than 3 tick 0 7. So I is equal to I plus b1. Okay, I is equal to 0. Okay. So hash 1 tarvata what are you doing? A of I is equal to A of I plus 1 tick b1. And ikkada one more for loop you are using here. So you are taking one more temporary variable k ఒకటి తీసుకున్నారు, I ఒకటి తీసుకున్నారు, j. So here what you are doing, j is equal to 0, j is less than 3 tick, yes 0 is less than 3 tick 0 7. So what are you doing? b of j is equal to j plus 1 tick b0. ఇది ఏంటిదనంటే జస్ట్ టెస్ట్ బెంచ్. ఓకే. సో టెస్ట్ బెంచ్ చూపిస్తే మీకు అర్థమవుతుంది. Segment of test bench to add a module for all input combinations. So for every time steps, total 8 bits are there. Okay, 4A and 4 of B and 1 C in changes. Okay, for every 2 power 9 possibilities, the test is carried out. So you write this and you can observe the test bench here. Okay? Initially you are taking, if k is equal to 1 అయితే carry is equal to 1 you are giving. So if this statement is not, this condition is false, and if k is equal to 0, what you are doing, carry in is equal to 0. Okay. So again you execute this beginning statement for how many times? 3 tick octa 7. 3 tick octa 7 times. Okay. So you execute this statement. What is this statement? A of I is equal to A of I plus 1 tick b1. అంటే A of I, B of I. ఓకే. సో వాల్యూస్ ఉన్నాయి కదా, మీరు ఏం చేస్తారు, ఇనిషియల్గా 0 పెట్టండి. ఎవ్రీ టైమ్ యూ ఇంక్రిమెంట్ 0 1. ఓకే. సో లైక్ దట్ A of I అంటే నార్మల్లీ ఇట్ ఇస్ 8 బిట్స్ కదా, 0 0 0 0 0 0 0 0. ఓకే. సో యూ ఇంక్రిమెంట్ ఎవ్రీ టైమ్. ఎలా ఎప్పటి వరకు ఇంక్రిమెంట్ చేస్తారు? 3 tick octa 7 times you increment the value of A. And B value also you increment B of J is equal to B of J plus 1 tick B0. Okay. So you change the value of B for till 3 tick octa 7 times. Okay. So this way you can write the test bench, or else you can give the values manually. ఇంత పెద్ద టెస్ట్ బెంచ్ నేను ఇంత పెద్ద టెస్ట్ బెంచ్ రాయాల్సిన పని లేకుండా I have written the test bench like that. So next one is disable construct. Disable construct. So it terminates the named block or task. Okay, if you want to come out of a loop, for loop నుండి బయటికి రావాలి, లేకపోతే ఒక బ్లాక్ నుండి బయటికి రావాలి, begin and బ్లాక్ నుండి బయటికి రావాలి అంటే I have to use the disable statement. So whenever you are using the disable statement, the control is transferred to the statement immediately following the block. Okay. So this is nothing but you can say that conditional termination of a loop. For loop execute అవుతుంది. Okay, I is equal to 0, I less than 7. అంటే this ఇక్కడ ఒక begin and block ఉంది. Okay, begin and block. So this begin and block should be executed 6 times. అంతే కదా. I is equal to 0, I less than 7, I plus plus అంటే, so 6 times this should be executed. కానీ now presently I am at I is equal to 3 and బయటికి వచ్చేయాలి అనుకుంటున్నాను 6 times execute అవ్వకముందే. So what I need to do, I need to use disable command. Okay, construct use చేయాలి. When I'm using disable construct, in between. So whatever the simulation control is there, it will be terminated. It will come out of the loop. Okay, that is the meaning of disable construct. Okay, so this is our module, OR gate module with disable construct. You can see this is OR gate. So input is 3 down to 0A, output is input enable, output is B. Now B you are storing in a range. Okay, integer is I. So during the positive edge of the block, మనం name చేయొచ్చు అన్నాను కదా begin and block కి you can assign the names to your begin and block. Okay, I have assigned name to the begin and block. So the name of my begin and block is OR gate. Okay, so initially you assign 0 to B. B is assigned with 0. So for I is equal to 0, I less than 3, I is equal to I plus 1. So initially I is equal to 0. Okay, you need to check this condition. A of I is equal to A of I is equal to A of 0. 1 na kada chudandi. Okay, so you see whether A of 0 is 1 or not. If A of I is A of 0 is equal to 1, how many input OR gate? A of 0, A of 1, A of 2 and A of 3. Okay, so you need to check whether OR gate can if one input equal to 1, all the inputs are equal to 1 whether. So you check whether A of 0 is equal to 1 or not. Okay, so if this condition is satisfying, execute this begin and block. Okay, so what you need to do, B is equal to 1 tick B1. You assign output is equal to చూడండి ఇక్కడ A of 0, A of 1. This is your OR gate 1. Okay, so A of input A of 0 1 ఉంది అనుకోండి, output will be equal to 1, right? Output will be equal to 1. Yes, here you check A of 0 is equal to 1. So yes, this condition is satisfying. You put B is equal to 1. Okay, OR gate ki ఒక input 1 ఉన్నా you will get 1. So B is equal to 1 and disable. మళ్ళీ మళ్ళీ అదేమంటారు, you need not go to A of 1 కి A of 2, A of 3 కి వెళ్ళాల్సిన పని లేదు. First input itself is equal to 1. What you need to do, you can declare that output is equal to 1 for an OR gate. Okay, output is equal to 1 for an OR gate. So disable, we output 1 petti, you come out of this loop. Okay, you come out of this loop. So second condition is if A of I is equal to 0. Okay, so first A of I is equal to 0 అయితే you what A of I is equal to 0. If this condition is not satisfying, then don't execute this loop. Don't execute this loop. Okay, don't execute this loop. Again you check, again you go back, and again you go back and check for A of I. Now I is equal to now I is equal to 1. 1 is less than 3. Yes. Okay, then A of 1, if A of 1 you are finding 1, so then put B of, then execute this loop, put B of 1 is equal to 1 and come out of this loop. No need to check for 2 and 3. Okay, similarly if A of similarly if A of 1 is also equal to 0. Okay, so this condition is not satisfying. If this condition is not satisfying, again go back and check for A of 2. A of 2 is equal to 0. This condition is not satisfying. Again go and check A of 3. Okay, so A of 3, this condition is not satisfying. So all are zeros. Then initially you have assigned, so your output will not change. Initially you have assigned B is equal to 0. It will be like that only. Whenever while executing this for loop, so at I is equal to 0 aina, I is equal to 1, I is equal to 2 దగ్గర aina, if you are finding anyone, put B is equal to 1, output is equal to 1 and come out of the loop. Okay, so this is your disable construct. Ganesh, you got the concept of disable construct?
Yes, ma'am.
This is the synthesized circuit. So using disable construct, identifying the highest priority pending interrupt. Okay. So now you have the name of this beginner block is source. Okay. Initially you are giving n is equal to 0, 0, 0, 1. Now for I is equal to 0, okay, I is equal to 0, yes, I is equal to 0. Yes, I 0 is less than 7, this condition is satisfying. You check A of I. What is A of I? A of I is equal to, if A of I is equal to 0, if A of I, ante I is equal to 0, ante A of 0 equal, if it is equal to 0, then what you need to do, increment the value of n. N is equal to n plus 1 tick b1. A of I is equal to 0. Ante you increment the value of n. That means 1, 1, 0, 0. It will become 0, 0, 1, 0. Okay. Or else if n is equal to 1, 0, 0, 1, what you need to do? If n is equal to 1, 0, 0, 1, what you need to do? N is equal, you need, if it is 1, 0, 0, 1 అయితే, you just assign zeros. Okay, n is equal to 1 to 3, 0 assign చేయండి. So this is here also, if you want to come out of this loop, ఈ loop లో నుండి I of what I less than equal to 7 వరకు అంటే 8 times execute అవ్వాలి this for loop. Okay, till I is equal to 7. Until I is equal to 7, you need to execute this begin and block. But in between, if you want to come out, ante ee condition undi. If n is equal to 1, 0, 0, 1 aithe, so what you need to do, you can come out of the loop by using disable. Okay, you can come out of the loop by using disable construct. Okay, so you try this program also. If you are not getting, I will explain it. Okay. Next one is while loop. While loop is so simple use. Evaluate the expression. If the expression is false, just stop it. If the expression is true, whatever the block is there, you execute. After the execution of the block, this is like forever. Okay. After the execution of the block, you come back again. Okay. So this is the explanation. So here generation of pulse of finite width. So pulse ante meeku telusu kada, this is the pulse. So the width of the finite width pulse ante, so positive and negative should be same. Ante ఇది 2 nanoseconds ante ఇది కూడా 2 nanoseconds ఉండాలన్నమాట. So how to generate the pulse of finite width using this while loop? It is a repeated execution of the block, right? So input I am taking n, okay, n which is of 8 bits. Clock is the input and enable is the input and output is p. So now whatever the output is there, I am taking a temporary register A. Okay, so output what I am getting a temporary register A which is of 8 bits and also 1 bit temporary register. During the positive edge of the clock, so you need to assign n value to A. Okay, now A is equal to, A is a register of 8 bits kada, A of 8, A of 7, okay, till you have A of 0. Okay, so A of 0. Now here you can see initially you are assigning n value to A. N is the input, right? N is also of 7 bits. It is a 7-bit input. It is edge. Okay. N is also, it is a 7-bit input vector. Edge లో స్టోర్ చేసాం కాబట్టి here I am writing A of 5, A of 7 till A of 0. Okay, N is an input of 7 bits, N7, N6, N5, N4, okay, till N0. Okay, so N you may take anything. నేను ఇప్పుడు 0, 0, 0, 0, 0, 1, 0, 0 వేసాను అనుకోండి. Whatever the N value, I am just assigning to A. Okay, so while this is OR, okay, bitwise OR, okay, bitwise OR. That means if all the inputs of A is equal to, if any, while OR అంటే bitwise OR కదా, so if all the inputs అంటే while OR అంటే A of 8 plus A of X or X, A of 8, sorry, A of 7 plus A of 6 plus A of 5 plus A of 4 up till A of 0 is equal to 1 అయితే. The meaning of this one is this. So you need to execute this beginning block. ఈ beginning block ఏంటిది? B. Temporary register B is equal to, you need to assign reg B. B is equal to 1 tick B1. Okay, B is equal to 1 tick B1 అంటే what is that? B is equal to 1. Okay, B is equal to 1. Okay, so during the positive edge of the clock, whatever you are doing, your increment n value మీరు ఒకవేళ ఇది అనుకోండి 0, 0, 0, 0, 0, 1, 0, 0. So now what you need to do, decrement the value, positive edge of the clock దగ్గర decrement the value of A అంటే so 0, 0, 0, 0, 0, you are decrementing by 1 bit కదా, 1, 1, 0, 0 అని అంటే will be 4 కదా, 1,
0, 1.
okay, like decrement A by 1. Okay, so after decrementing you put B is equal to 1 tick B0. Okay, so you execute this endlessly, 0, 0, 0, 0, 0, మళ్ళీ 1 tick decrement B 0, what you will get? 0, 1, oh sorry, 1, 0 you will get. Okay, so like that you need to decrement the value of A. So ఇక్కడ కన్నా మీకు if you see the test bench, the simulation results will give you. Okay, so clock, for every positive edge of the clock you need to decrement, right? See, this is the positive edge of the clock, positive edge, positive edge, positive edge, positive edge. Okay, positive edge of the clock దగ్గర, so what are you doing? Output B is equal to 1. Okay, so output B is equal to 1. A value is not given here. So actually, let me simulate this program and I will get back to you. ఎందుకంటే కొన్ని తప్పులు ఉన్నాయి దీంట్లో. So generation of pulse of finite width అంటే, so if we are getting, so అన్ని ones 4 ones వస్తే 4 zeros రావాలి, 0, 0, 0, 0. ఓకే, మళ్ళీ 4 ones వస్తే 4 zeros రావాలి. Okay, like that you should generate the pulse. Okay, so we'll see this tomorrow. Rest of the things we'll see tomorrow. We will close the session now. So many things are there. Okay. So రేపు నేను ఆ pulse program చెప్తాను, and at the same time we'll see other things also. So I'm closing the session 10 minutes before. Okay, Ganesh, you practice.
Okay, ma'am.